States Aerospace Institute over here at Embry-Riddle. Today I'm going to walk you through some simple steps to creating a Pix4D capture mission, flying that mission, and then uploading it to the Pix4D cloud. And then I'll show you some tips and tricks on how to use the Pix4D cloud. It's got some great tools in there. All right, let's get started.
Okay, let's get right into it. The first thing that we need to do is complete a site survey and make sure we can fly legally. So let's hop on to Google, and we'll go to Maps. I will be flying at a location today, beachside, that I have permission from the owner to fly at. So we're just going to transfer over to satellite images, and we will find the location we're going to fly. Once we find the location, we can use Google Maps to not only find any hazards among the flight, but locate power lines, light poles, trees, anything like that. Let's go ahead and click the what's here. This is going to give us the coordinates for where we are, and this will allow us to copy and paste those into a sectional to see where we are in the National Airspace System. So let's head over to skyvector.com. We'll go ahead and open that up, and we'll select the flight plan option, which will allow us to copy and paste those coordinates in, and it will pop up right on the map where we are. So once we punch in the coordinates, we'll hit enter, and you'll see a little dot appear on the map. And we'll go ahead and we'll put it in from Daytona airspace to see how far we are from the airport, and we are 3.6 nautical miles, which means indeed that we are at the surface in Class C airspace. So we need to get permission to fly there. So the next thing that we are going to do is go on over to airmap.com. Now, this is also an app that you can use on your iPad provided by GAI, but sometimes it's just easier to use the website. So we'll hit this little plus here, and we will go into the flight planning mode. We are in a 300-foot block, which means we can fly up to 300 feet with permission from the FAA. I already have the location in there from before, so I'm just going to adjust it ever so slightly to get the full place that I'm flying, and then I will answer some simple questions on the right hand side. You can see enter in time, date, how long my flight's going to be, my name, the type of aircraft I am flying, will it occur over people, no, and will it remain in visual line of sight? That is yes, the weight of the aircraft, and then we will go ahead and we will hit brief flight plan. This will bring up our weather. It's actually a pretty cloudy day here, which is good for 3D maps. So then we hit submit flight plan, but remember, we are not actually able to fly there until we get text message verification from the FAA that says we can fly there, so we'll wait for that. Our flight plan is submitted successfully, and let's wait for the text message. The site survey out of the way, let's go ahead and plan a mission in Pix4D Capture. We'll open up the app and we'll go to settings in the top left hand corner. This will bring up the type of aircraft that we would need to select. We're doing a Mavic Pro today, and we'll go to double grid right there in the center for a 3D map. Now on the maps, we need to find the location that we are going to be flying, and you can do that a couple ways. One is dead reckoning, just figuring out where you are, and another is using this little blue dot. That's going to be your Wi-Fi location, so it's not always accurate. When it is, you go ahead and just tap right on the map, and it will bring the flight plan over to where you are. Adjust it as so, and remember that you always want it to extend a little bit beyond what you're trying to map, because it won't include exactly everything. But again, remember, you don't want to fly in airspace or at a location that you do not have permission. So make sure you get it set up correctly here, and then you're going to go ahead and adjust the height. 50 feet above the highest obstacles is always a safe bet. Here we're at 115. Now go into settings in the top right hand corner, and this will allow you to change the overlap and the speed of the drone. You want the overlap to be as good as possible. The higher overlap, the better the image quality will come out, and we want the drone to fly essentially as slow as possible to take the most crisp pictures. If we go to advanced settings, there's one thing to check down on the bottom: ignore home point. We want to make sure that's set to no. It automatically is, but it's always good to give it a second chance. And we'll just go ahead and change the picture trigger mode to safe mode. This is going to make the drone stop at every picture. The last thing that we're going to do is go back to our main screen, and we are going to save this. We'll press the bottom right floppy disk, and it will save it. And we can see that there's a map loading feature in the top right hand corner. You've completed all the pre-flight work. Let's grab a checklist and head outside. Here I'm using a digital form of a checklist, which will soon be available to everyone. Let's go ahead and check out the status of the aircraft by pressing the status tab on the right hand side. Make sure everything's good to go. Next we'll move down and we will hit that start button, which will bring up a screen to confirm that we are connected. We'll hit the next button and we will wait for the aircraft to perform its self checklist. Wait for little green check marks on all of those and we'll hit the start button to take off the aircraft and launch it into the air. Once it's in the air, be prepared to follow along with you and your visual observers to ensure that you remain within visual line of sight of the aircraft at all times. At the end of the mission here, I hit the pause button on the screen so I could come in for a manual landing. This was probably not necessary, but seeing as there was a few trees around me and I was a little bored, I thought I might take over. The drone's off and remove the SD card from the drone. Plug the SD card into an adapter with a USB and plug the USB into your computer and navigate to the Files page. Once you navigate to the Files page, go ahead and open up where all your pictures are. Right click on your desktop and you're going to want to create a new folder to copy and paste all of those pictures. Remember, data management is extremely important, so label the folder according to the pictures. And you can go ahead and select them all, drag them in there, and wait for them to copy over. The reason we're going to save it on the desktop is so that we can upload it and not worry about the communication from the SD card to the server, rather from the computer to the server. Take out the middleman. Alright, now let's go ahead and open up Safari or Chrome, whatever you'd like, and we'll go to the Pix4D cloud. So we'll put that link right here, cloud.pix4d.com/pro. If you need the login information, please reach out to me. From here, we're going to go ahead and select New Project. And again, we'll put in the title of your project, whether it's your school name or this test project, whatever it is, put it in. Make sure to label it with a date as well. Now go ahead and select the images from the file that you just created on your desktop. You can select one and then press Control A to highlight them all. Go ahead and hit open and then hit upload and process. And all you have to do is sit back, relax, and wait for those to upload.
Alright, now let's go ahead and we can see that our project has indeed been processed with this green little process badge in the top right hand corner. We'll go down and we'll hit open. Now keep in mind that this is going to actually depend a lot on your internet connectivity. So if you're on Wi-Fi, it might be better for you to get plugged in now. So let's try and do that. Alright, first thing that comes up is our DSM. The DSM is the Digital Surface Model, and that's going to be over the 2D ortho mosaic map. So this tells us the altitude of the different objects within the map. Obviously we can see that the trees are at the highest here. Looks like we have a power line that might be high over here as well and here as well. Very simple, easy to use. Anything that's in red is usually the highest, and the lighter blue it is the lower it is. Alright, let's go ahead and take that DSM off, and we can see that we have a great 2D map here. It's very updated, way better than Google Maps. In fact, it just happened a few minutes ago. But what we're really interested in today is the 3D map. So let's go ahead and hit the 3D button down here in the left-hand corner. And here it is. It will take a minute to load, but that's alright. By right clicking, you can move around the map like so. And by left clicking, you can pull and drag the map as well. Let's go ahead and get a good visual position while the map still loads. You can see that we can zoom in, we can do a whole lot. Right off the bat here, it looks like we have some patches that we need to fill. So let's go ahead and use our marker tool on the left hand side here, and we'll add in some markers to remind ourselves to go take pictures in the future. And we'll make that a green tag. Alright, and then we can add in a couple more of those, and we can just make them green so that we know what it means. Let's look at the top here. Alright, we can see there's some patches in the roof. We can throw a marker in there, and we'll say possible roof damage. And we will make that color red. Alright, we'll hit enter, and we'll find a couple more roof damage places that may look possible. Again, this just might be the 3D map is a little incomplete. Alright, so we had those labeled. The next thing we want to do is actually find out the length of this driveway. Let's see. We'll go up here and we'll use our measure and distance tool. So we can click on that. We'll drop the first point right there with the left click, and we'll come all the way out to the street with the right click. And when you right click, that actually ends the shape as well. And we can see that we have a 53.477 foot driveway. And if we go over here and we use generate elevation profile, now this is a pretty even driveway, but we're going to go ahead and see if there's any slope in there or anything like that. It will take a minute to generate, but it's actually an extremely useful tool. Not so much for driveways, but for different things like parking garages where they need to control water flow. While that's loading, let's take a look at our other tools up here in the top right hand corner. We have a measure an area option, which just like the line option, you can highlight an area and it will tell you the exact square footage of it. Alright, very cool. It looks like our image has been generated, so let's go ahead and move over to our driveway here. And by using this, we can see exactly where it jumps up. We do see it has its gradual slope down. What is this jump up though? Maybe I selected something wrong, so let's keep it right about there. It looks like I might have selected the tree, and we'll zoom in. Whoops. Yeah, you can see that I actually selected the roof there instead of the driveway, so a more accurate finding would have been found from this angle. So let's go ahead and go back to our marker here, and we'll select something that looks a little bit better. So this looks a little bit better, and we'll right click to end that, and we can see that it's a little bit straighter, not too much of a slope. We basically followed the driveway the whole thing. So that's a very useful tool. Again, we were talking about the square footage tool, so we can go ahead and select that. Let's figure out the square footage of this room over here on the back side of the house, and we'll right click to end it, and it is 278 feet squared, which is pretty good. There's a 1 foot elevation difference. That could be due to the model itself or whatnot. We can also use the inspect tool. So now let's go back to these images, and we'll go ahead and select right here, and all of our images associated with that image will pop up. So we can see we have all the different images down here and all the different images down here, and actually there's quite a lot of them. But as we can see, there's really nothing in there that proves there is a damage to the roof. It looks like it's just a glitch in the software. So we'll go ahead and look at our other tools here. The only last one that we have left is the volumetric tool. Nothing in here is going to be very useful for the volumetric tool, as it's usually mainly used to measure the amount of sand on a pile of sand or something like that. But go ahead and you can play around with it, and you can figure out the volume of a whole bunch of different things. If we look at this shed, for instance, in the back here, we can can go down here and then we can calculate the volume by triangulating it. Now this does take a little while, so I'm not going to show you today, but feel free to go out, fly a mission, do this and have some fun, and then go ahead and mess around with all the different settings until you get acquainted with them. Alright, thanks for tuning in.